Okay? And very interestingly, the K0I and the K0R has to be same as the K1T. So omega has to be same. I mean, to have this equality, the exponent has to be same, right? Okay. You are not very comfortable, right? I can see from your face. My job is to make every student comfortable. Why you are not comfortable? Because of my shirts or? 왜 튀어나왔냐고? Huh? Okay, that's a good question. Okay. Pressure on x equals 0. Right? Pressure on x equals 0 can be obtained by putting x equals 0 over here, right? Okay, don't mix your way of thinking. What I said is, let us first express the physically observed things mathematically. Okay? And then what we are doing is we are going to use the property of mass to find out what we do not know. So once we establish mathematical form, then what we do, we just express everything in terms of form. So how to express pressure on x equals 0? It's this. Of course, I do have a curiosity. Oh, what the hell? This Ki, why? Oh, what is this? Of course, I have a curiosity too, right? But that will peel out. That will come out when we solve all the problem mathematically, rationally, right? So, of course, that's of course very good question. This means K0I and K0R and K1T the same. Do you think that is correct? Do you think that is correct? And what is K0I? Oh, sorry, K0XI. No, K0XI, right? K0, but in X direction. So XI. Oh no, Y? K0Y? Y, K0Y. Y. In other words, wave number in Y direction. What is wave number in Y direction? That is K0. According to sign convention over here, that is sine theta I. And this is K0 sine theta R. And that is K1 sine theta T. Therefore, I can say incident angle has to be same as the reflected angle. Right? But we cannot say theta I is equal to theta T. From this observation, what we can find is that famous Snell's law. famous Snell's law that says K0 sine theta 0, that means incident angle as well as reflected angle has to be same as K1 sine theta 1. Theta 0 and theta 1 is simply the angle of incidence from medium 0, and the theta 1 is the angle of transmission at medium 1. And note that K0 is omega over C0, therefore I can write sine theta 0 over C0 is equal to sine theta 1 over C1. That looks very familiar to you guys, and you saw it when you were in high school or middle high school or maybe in elementary school. Yeah? I mean, we knew that long time ago, and maybe your teacher said that, oh, this is Snell's law. And your teacher explained what it means. But what we did, we used mathematical form and using mathematical reasoning to get what we observed physically. So again, this is the power of physical thinking. Okay, this is the power of math. Sewan, huh? Right? Now you understand, huh? Okay, then what does it mean? Let's look at what does it mean over here. Okay, this is K vector, and K sine theta is how many waves in this direction? Right? And KR sine theta R is number of waves in this direction. Has to be same as number of waves in this direction due to transmitted wave. Right? So in fact, the number of waves propagating in y direction is the same in both medium. That we call trace wave number. Trace wave number meaning that we are tracing wave number in y direction. Okay, similar things would happen over here. The trace wave number of this medium has to be same as the trace wave number that happened in the plate. But the plate case, the wave number in plate KB, later on I will write KB is to express bending wave, is depending on the property or characteristics of plate. Plate bending rigidity, plate's mass per unit area, thickness, and so on. Okay? Now, this Snell's law is the conclusion of geometrical requirement. Right? That means that we can see from this figure geometrically that the number of waves in this direction has to be same as number of waves in this direction in both medium. Okay. Nothing very special. We just come back to our elementary school or middle high school age. Okay.